Let me show you how to find the vertical acceleration of a rocket. This is a little bit tricky, and it's going to take a bunch of steps, but the basic steps are these. The first thing is we've got to find the initial mass and the final mass of the rocket, right? Sometimes we've got to figure out the amount of fuel we have too, which makes it sort of tricky here. Okay, so for example, in this problem here, we've got a rocket that has a total mass of 12 kilograms. Most of that mass is fuel, and this is not uncommon for a rocket, is that most of its mass as it sits on the launch pad is fuel. So the initial mass is the 12 kilograms, right? It's got all the fuel in it, 12.0 kilograms. And the final mass is going to be 2 kilograms. And that devilry, by the way, was 12 minus 10, right? So this is the amount of fuel that we have, right? Okay. So the fuel mass, maybe we should, that's final mass, right? And then the fuel is equal to 10 kilograms, right? Okay. So that's sort of our first step, is let's sort out all these masses. What's our initial, what's the mass of the rocket, the total mass initially? What's the final mass of the rocket right before it runs out of fuel? And then how much fuel do you have? You got to figure that out. You got to think about this. Slow down. Take a moment to think about that. Okay? That's our first thing. Okay? Our second thing is we got to find the thrust of the rocket. Okay, so to do that, we're going to go force times time is mass change in velocity, right? Okay. Now, when we fill this in, okay, the force is going to be the thrust of the rocket. Notice in this case, in this type of problem here, they're telling us that it's 8.5 seconds and 10 kilograms of fuel is burned. So let me just show you how to set this up, right? The force times, we have 8.5 seconds, right? Seconds, right, equals the mass. Now here it is. We got this mass, this mass, this mass, okay? This mass has to be the fuel mass. Most of my kids, when they make mistakes, they make a mistake and they don't use the fuel mass. They use either the initial mass of the rocket, the final mass of the rocket, or I don't even know what they do. Okay, but this has to be the fuel mass. So there's 10 kilograms of fuel. So I'm going to go 10 kilograms there, right? And then our exhaust velocity is 420 meters per second. That's what the V is, right? Now I'm going to use my calculator here. Okay, and I'm going to go this times this divided by this. Times divided by, all right. And that's 494.1. newtons. There we go. So that's my second step. Those are fours, 494.1. All right. And then the final step here is to find, so step 3 and 4, right, of those things, is find the initial and final acceleration. So let's divide up our space here. All right. There we go. So step 3 is find the initial acceleration. A initial, right? Now, why does the acceleration change? Well, the thrust doesn't change. We're going to assume that that engine has that thrust the whole time, but the mass of the rocket ship changes from 12 to 2. So at first it accelerates more slowly. At the end, it's got less mass to accelerate, so it's going to accelerate faster. Okay. So and then the fourth step is find the final acceleration, right? So let's draw ourselves a picture. Here's our initial rocket, right? The upward force is 494.1 newtons, right? The downward force, remember this is a 12 kilogram rocket. The downward force is 12 times 9.8, right? So 12 times 9.8 is 117.6. Right, so don't forget, this is the weight. This is the thrust. Let's assume the rocket is pointed upwards, right? So the force that you get here becomes the upward force, right? Okay, and then you have to, don't forget the force of gravity, right? Okay, and now we're all set. Now we can set up one of these equations, right? Force up minus force down, this will be negative, right? That'll be positive. Force up minus force down is ma, right? So we go 494.1 minus 117.6. That's going to equal 12 times A. And now we can solve for A. So here we go. I'm going to go 494.1 minus the answer I just got. I get 376.5 is 12A, and now I just have to divide by 12. I'm so excited. Okay, I get 31.4 roughly meters per second. It's 31.375. But notice how we have 3 digits, 3 digits, 3 digits, 3 digits, right? We're going to round that to 3. So that's my initial acceleration. There we go. Let's find our final acceleration. So let's draw a picture of the rocket again. Oh, wow, that was interesting. All right, and then here's our fins like this, right? And our upward force is still 494.1. We're assuming that until that last atom of fuel goes away, right? That's saying that upward force doesn't change, right? Our downward force, though, this is only a 2 kilogram rocket. And 2 times 9.8 is 19.6, right? I'm checking it as we speak. 19.6, right? So the downward force is small. 2 times 9.8 is 19.6. And that guy's going to be negative. This guy will be positive. And now we'll set up our little equation here. Boop, boop. 494. This is Newton's second law, by the way, is what we're doing here, right? Minus 19.6 is 2 times A, okay? So notice that 2 things change, right? I mean, it's really one thing, but it's causing 2 changes in the equation. One is that the force of gravity is less in this case, and the other is that the inertia is less. All right, so here we go. 494.1 minus 19.6 is 474.5, and that's 2A. So divide by 2. 237.25, right? So A is be careful you don't round this too much. Like notice how I carried like 4 digits there. You might carry another decimal point, or just use the up arrow on your calculator. Use that actual number if you know how to do that. Other than that, I mean, it's pretty basic, right? So be sure to think about it. Think about what the masses are, right? Figure out the initial mass, the total mass of the rocket, so total. But also figure out how much is fuel, right? Sometimes it's hard to do that, but there it is, right? And then remember that when you do this, this is where most of the mistakes are done. That's got to be the fuel mass, okay? This is your exhaust velocity, right? This is the time it takes to burn the fuel. And then this will be the thrust, okay? Yeah. All right. I think we're good.